Hi guys, tonight we're going to explore one of the most radical transformations imaginable. What if Earth suddenly became flat overnight? What if you woke up tomorrow to discover our spherical planet had been pressed into an enormous disk, with Antarctica forming a massive ice wall at the edge of the world? If you enjoy these reality-bending sleep stories that explore impossible scenarios and their cascading consequences, hit that like button and subscribe for more. And drop a comment letting me know what time it is where you are and where you're listening from. It's great to connect with all of you wherever you're drifting off tonight. Alright, let's begin. In the crisp morning light of a Tuesday in September, Captain Sarah Martinez banks her Boeing 747 sharply to the left, beginning what should be a routine Great Circle route from Los Angeles to Tokyo. But today, something is fundamentally different about our world. Today, the Earth beneath her wings stretches out as a vast, impossibly flat disk, extending in all directions like an endless tabletop suspended in the cosmos. As her aircraft climbs to its cruising altitude of 37,000 feet, Martinez stares out at a horizon that behaves in ways that challenge everything she learned in flight school. The transformation happened overnight, as if some cosmic force had taken our familiar spherical planet and pressed it flat like dough beneath an infinite rolling pin. The disk that was once Earth now measures approximately 25,000 miles in diameter, maintaining the same surface area as our former sphere, but redistributed across a single, impossibly flat plane. The continents sit arranged much as they were before, though their relationships to one another have shifted in ways that will soon become apparent to every navigator, pilot, and GPS system on the planet. At the centre of this vast disk lies the Arctic region, with the North Pole serving as the absolute centre point. From this hub, the familiar continents radiate outward like pieces of an enormous jigsaw puzzle. North America stretches southward and eastward from the central Arctic, while Europe and Asia extend in great arcs around the northern portions of the disk. Africa occupies a position that places it roughly halfway between the centre and the rim, while South America, Australia and Antarctica are distributed around the outer regions of this impossible geography. But it is Antarctica that presents the most startling transformation of all. No longer the familiar ice-covered continent we once knew, Antarctica has become something unprecedented, a towering ice wall that rises from the southern oceans to form the edge of the world itself. This wall of ice stretches upward for miles, creating an impenetrable barrier that encircles the entire flat Earth like the rim of an enormous dinner plate. The wall averages approximately 2 miles in height across its entire circumference of roughly 78,000 miles, containing an estimated volume of ice equivalent to 27 billion cubic meters per linear mile. The immediate consequences of this transformation ripple across every aspect of human civilization. In the control towers of airports from Heathrow to Narita, air traffic controllers stare at radar screens that no longer make sense. Flight paths that once followed the predictable curves of great circles around a sphere now require complete recalculation. The flight from London to Sydney, which previously covered approximately 10,500 miles over the curved surface of a sphere, now requires aircraft to traverse nearly the entire diameter of the flat disk, a journey of roughly 20,000 miles across the flattened landscape. Captain Martinez, still climbing toward her assigned altitude, radios back to Los Angeles International Airport. Her voice crackles with bewilderment as she reports coordinates that place her aircraft in a position that should be impossible according to every navigation system on board. The GPS satellites, orbiting in their carefully planned constellation above what was once a spherical Earth, now find themselves scattered across the dome-like sky above a flat world, their signals creating interference patterns that render global positioning systems completely unreliable. In the telecommunications centres of major cities around the world, engineers scramble to understand why their satellite networks have suddenly failed. The geosynchronous satellites that once maintained fixed positions above specific points on Earth's surface now orbit in confused ellipses above the flat disk, their carefully calibrated orbital mechanics rendered meaningless by the new geometry of space. Communication satellites designed to provide coverage based on the curvature of a spherical planet now cast their signals across a flat surface in patterns that leave vast areas without coverage while creating interference zones where multiple satellites overlap. The financial markets, those sensitive barometers of global stability, react with unprecedented volatility to the morning's revelations. In Tokyo, where trading has just begun, the Nikkei index plummets by 37% in the first hour as investors grapple with the implications of a fundamentally transformed world. The New York Stock Exchange, preparing for its opening bell, faces a crisis unlike any in its history. Commodity prices for everything from oil to wheat fluctuate wildly as traders attempt to recalculate supply chains and transportation costs across a world where distance itself has been redefined. Oil companies face particular challenges as they realize that pipeline routes planned for a spherical Earth now traverse completely different terrain on the flat disk. The Trans-Alaska Pipeline, designed to carry oil 800 miles from Prudhoe Bay to Valdez, now finds itself in a landscape where these 2 points are separated by entirely different geography. The pipeline infrastructure, representing billions of dollars in investment and carrying approximately 2 million barrels of oil per day, requires complete reassessment in a world where north no longer leads toward a pole, but toward the center of a vast disk. In the wheat fields of Kansas and the rice paddies of Vietnam, farmers step outside their homes to witness sunrises that behave in ways that defy explanation. On a spherical Earth, the sun's path across the sky varies predictably with latitude and season. But on a flat Earth, the sun must somehow illuminate the entire disk surface, creating patterns of light and shadow that challenge every assumption about day and night, seasons and climate. The sun itself, now positioned above the flat Earth rather than at the center of a solar system, follows a spiral path across the sky. During what was once summer in the northern hemisphere, the sun traces tight circles above the central regions of the disk, providing extended daylight to areas near the former North Pole while leaving the rim regions in relative darkness. As the seasons progress, the sun's path expands outward in ever larger circles, bringing longer days to the middle latitudes while the outer edges of the disk experience their brief summer seasons. This new solar geometry creates climate patterns that render existing weather prediction models useless. The National Weather Service, the European Centre for Medium-Range Weather Forecasts, and meteorological services worldwide find their supercomputers generating predictions based on atmospheric physics that no longer apply to the flat world's reality. Storm systems that once followed predictable patterns around a spinning sphere now behave according to entirely different rules on a flat surface. Hurricane formation, which depended on the Coriolis effect generated by Earth's rotation, undergoes fundamental changes. On a flat Earth, the rotation that once drove these massive storm systems now creates different patterns of air circulation. Hurricanes still form over warm ocean waters, but their paths and intensities follow new rules that meteorologists struggle to understand. The Atlantic hurricane season, which typically produces 12 named storms with sustained winds exceeding 39 miles per hour, now generates weather patterns that move across the flat surface in spirals that converge toward the center of the disk or spread outward toward the ice wall rim. In Miami, Hurricane Center forecasters track a developing storm system in the Atlantic that behaves unlike any hurricane in their historical records. The storm, which would have followed a predictable curved path around the spherical Earth, now moves in a pattern that carries it in a nearly straight line across the flat surface. Wind shear patterns, temperature gradients, and pressure systems all respond to the new geometry of the flat world, creating weather phenomena that existing models cannot predict. The ocean currents that once circulated around the globe in great gyres now flow in patterns determined by the flat Earth's unique geography. The Gulf Stream, which previously carried warm water from the Gulf of Mexico up the eastern coast of North America, before crossing the Atlantic to warm Europe, now follows a path that curves around the disk in ways that alter global climate patterns. The stream carries approximately 30 billion gallons of water per second at temperatures averaging 5 degrees Fahrenheit, warmer than surrounding waters, but its new path across the flat Earth redistributes this thermal energy in unprecedented ways. European cities like London and Paris, which previously enjoyed moderate climates due to the Gulf Stream's warming influence, now experience weather patterns that reflect their new positions on the flat disk. London, situated at approximately 51 degrees north latitude on the former sphere, now occupies a position roughly 4,000 miles from the central Arctic region of the flat Earth. The city's climate, previously moderated by maritime influences and the Gulf Stream, now responds to atmospheric circulation patterns that flow across the flat surface in straight lines, rather than following the curved paths of a spherical planet. Agricultural systems worldwide face unprecedented challenges as growing seasons shift according to the new patterns of solar illumination. The Corn Belt of the American Midwest, which previously produced approximately 14 billion bushels of corn annually across 90 million acres, now experiences daylight patterns that alter photosynthesis rates and growing cycles. Farmers in Iowa and Illinois, accustomed to predictable sunrise and sunset times that varied gradually with the seasons, now witness solar patterns that create entirely different agricultural conditions. Rice production in Southeast Asia, which feeds more than 3 billion people worldwide, faces similar disruptions. The rice paddies of Vietnam, Thailand, and southern China, which previously produced crops based on monsoon patterns driven by spherical Earth weather systems, now experience precipitation and temperature cycles that follow the flat Earth's unique atmospheric dynamics. The annual rice harvest, typically yielding approximately 740 million metric tons globally, requires complete recalibration of planting and harvesting schedules. Ocean navigation, which has guided human exploration and commerce for millennia, undergoes fundamental transformation. The great shipping lanes that connect continents across spherical ocean surfaces now cross entirely different water bodies on the flat Earth. The container ships that carry 90% of global trade, vessels capable of transporting 24,000 20-foot containers each, now navigate waters where compass readings lead toward the center of the disk rather than toward magnetic poles. The Port of Singapore, which handles approximately 37 million 20-foot equivalent units of cargo annually, finds itself in a position on the flat Earth that alters its role as a global shipping hub. Ships travelling between Europe and East Asia, which previously followed great circle routes around the curved Earth, now traverse paths across the flat surface that may require entirely different port facilities and logistics networks. In the Strait of Malacca, one of the world's most important shipping channels, vessel traffic controllers manage the passage of approximately 25% of all globally traded goods. On the flat Earth, this strait occupies a different relative position to major ports and markets, potentially altering trade flows worth trillions of dollars annually. Ships carrying crude oil from Middle Eastern ports to refineries in Asia now follow routes across the flat surface that change fundamental calculations about transportation costs and delivery times. The Panama Canal, an engineering marvel that handles approximately 6% of global trade worth over $270 billion annually, finds its strategic importance dramatically altered on the flat Earth. The canal, which previously provided a crucial shortcut between Atlantic and Pacific shipping routes on a spherical planet, now connects bodies of water that occupy entirely different positions on the flat disk. The lock system that raises ships 85 feet above sea level to cross the continental divide now serves shipping routes that follow the new geometry of the flattened world. Naval forces worldwide scramble to adapt to oceanic conditions that render their strategic doctrines obsolete. The United States Navy, with its fleet of 11 aircraft carriers and approximately 485 vessels, must recalculate operational ranges and deployment strategies for a flat world where ocean distances have been fundamentally altered. Aircraft carriers designed to project power across spherical ocean surfaces now operate in waters where line-of-sight communications and radar coverage follow different rules. Submarine warfare, which previously relied on the Earth's curvature to hide beneath the horizon, now faces a flat world where visual detection ranges extend much farther across open water. Nuclear submarines, capable of remaining submerged for months while travelling at speeds exceeding 25 knots, now navigate underwater terrain that follows the contours of the flattened ocean floor. The world's fishing fleets, which harvest approximately 96 million metric tons of fish annually to feed global populations, discover that fish migration patterns have shifted according to the new ocean current flows. The Grand Banks off Newfoundland, historically one of the world's richest fishing grounds, now occupies a different position relative to ocean currents that carry nutrients and support marine ecosystems. Commercial fishing vessels that previously followed predictable seasonal patterns now search for fish populations that migrate according to the flat Earth's altered marine environment. Telecommunications infrastructure faces unprecedented challenges as engineers attempt to maintain global communications across a flat world. Undersea cables that carry 99% of international data traffic, including internet communications and financial transactions, now connect continents across ocean floors that follow entirely different topographies. The transatlantic cables that link North America and Europe, carrying data at speeds approaching the speed of light, now traverse underwater terrain that has been completely reconfigured by the Earth's flattening. Satellite internet services, which promise to provide global broadband coverage through constellations of thousands of small satellites, find their business models disrupted by orbital mechanics that no longer apply to a flat world. Companies planning to deploy satellite networks worth billions of dollars now face skies where their spacecraft follow entirely different paths above the flat surface. The International Space Station, orbiting at an altitude of approximately 250 miles above what was once a spherical Earth, now finds itself in a unique position above the flat disk. The station, travelling at 17,500 miles per hour in its former orbit, now follows a path that carries it across the flat surface in patterns that provide entirely different views of the transformed world below. Astronauts aboard the station report seeing the curved edge of the flat disk rising above the horizon like an impossibly vast mountain range. Ground-based telescopes that once observed the night sky from different latitudes on a spherical Earth now study stars from positions distributed across the flat disk. The Hubble Space Telescope, orbiting above the flattened world, captures images of distant galaxies from a perspective that challenges existing theories about the universe's structure. The cosmic microwave background radiation, which provided evidence for the Big Bang theory based on observations from a spherical Earth, now appears different when viewed from various positions across the flat surface. Radio astronomy installations like the Very Large Array in New Mexico, which uses 27 individual radio telescopes to study cosmic phenomena, now detect signals from space that reach the flat Earth from directions that don't align with previous astronomical observations. Radio waves from pulsars, distant galaxies, and other cosmic sources now arrive at the flat Earth following paths that create interference patterns across the disk's surface. The Global Positioning System, which revolutionized navigation with its constellation of 31 satellites, providing location data accurate to within 3 meters, faces complete obsolescence on the flat Earth. GPS receivers that once triangulated positions using signals from multiple satellites now receive confusing data from spacecraft orbiting above a world where the geometry of space itself has changed. The economic impact of GPS failure affects industries worth trillions of dollars, from agriculture to transportation to financial services that rely on precise timing signals. Farmers using precision agriculture techniques, which optimize crop yields through GPS-guided tractors and satellite-monitored field conditions, find their equipment unable to function in the flat world. Agricultural operations that previously achieved crop yields of 170 bushels of corn per acre through GPS-guided planting and harvesting now face significant productivity challenges without reliable positioning systems. The aviation industry confronts its greatest crisis in history as pilots attempt to navigate skies above a flat Earth where traditional navigation methods no longer apply. Commercial aviation, which transports over 4 billion passengers annually on flights totaling approximately 38 million departures, faces the possibility of complete grounding until new navigation systems can be developed. Airlines with fleets worth hundreds of billions of dollars find their aircraft unable to navigate reliably between airports on the transformed world. Air traffic control systems that managed approximately 100,000 flights daily across the spherical Earth now struggle to track aircraft positions above the flat disk. The Federal Aviation Administration's next-gen air traffic control system, which cost over $40 billion to develop, requires complete redesign for a world where aircraft follow different flight paths across flat geography. International borders, established over centuries of diplomacy and conflict on a spherical Earth, now require renegotiation as nations discover their territories occupy entirely different relative positions on the flat disk. Countries that shared borders along meridian lines on the sphere now find their territories separated by vast distances on the flattened surface. Island nations that once defined their territorial waters based on spherical coordinates now claim maritime boundaries using entirely different geometric principles. The European Union, with its carefully negotiated borders and customs arrangements among 27 member nations, faces unprecedented challenges as member countries discover their new positions relative to each other on the flat Earth. Trade agreements that assumed specific geographic relationships between nations now require renegotiation based on the altered distances and transportation routes across the flat surface. Time zones, which previously followed logical patterns around the Earth's spherical surface, become meaningless on a flat world where the sun illuminates the disk according to entirely different patterns. The international date line, which marked the transition between calendar days on opposite sides of the spherical Earth, now requires complete reconceptualization for a flat world where day and night follow spiral patterns across the disk's surface. Financial markets that operate across multiple time zones find themselves unable to coordinate trading hours and settlement procedures without the familiar rhythm of day and night following predictable patterns around a spinning sphere. The London Stock Exchange, New York Stock Exchange, and Tokyo Stock Exchange, which previously operated in a 24-hour cycle that followed the sun around the spherical Earth, now attempt to synchronize trading activities across a flat surface where daylight patterns follow entirely different rules. International banking systems that process trillions of dollars in daily transactions rely on precise timing synchronization provided by GPS satellites. Without reliable timing signals, electronic funds transfers, credit card processing, and other financial transactions face potential disruption that could paralyze the global economy. SWIFT, the international banking messaging system that handles over 42 million messages daily, worth approximately $150 trillion annually, requires emergency modifications to function without GPS timing references. Power grids that supply electricity to billions of people worldwide discover that their load balancing systems no longer correspond to predictable patterns of day and night. Electrical demand that previously followed the sun around the spherical Earth now faces entirely different consumption patterns as daylight and darkness spread across the flat disk according to new rules. The electrical grid systems of major nations, representing infrastructure investments worth trillions of dollars, require fundamental restructuring to accommodate the flat Earth's altered day-night cycles. Solar power installations that generate electricity based on predictable sun angles and daylight hours find their output patterns completely changed by the flat Earth's new solar geometry. Solar farms that previously produced electricity according to well-understood seasonal variations now experience power generation cycles that follow the sun's spiral path across the flat disk. The renewable energy sector, which represents hundreds of billions of dollars in global investment, faces uncertainty as solar panel installations require repositioning and recalibration for optimal power generation on the flat Earth. Wind power systems that harnessed atmospheric circulation patterns driven by the spherical Earth's rotation now operate in a flat world where wind patterns follow entirely different rules. Wind farms that previously generated electricity from predictable seasonal wind patterns now face atmospheric conditions that respond to the flat Earth's unique geography. Turbines designed to capture wind energy based on spherical atmospheric dynamics now spin in air currents that flow across the flat surface according to new meteorological principles. Ocean thermal energy systems that exploited temperature differences between surface and deep waters on the spherical Earth now operate in seas where thermal gradients follow patterns determined by the flat disk's geometry. Wave energy systems designed to capture power from ocean swells generated by storms moving around the spherical planet now face wave patterns that propagate across the flat ocean surfaces according to different hydrodynamic principles. The pharmaceutical industry faces supply chain disruptions as manufacturing facilities discover they can no longer reliably transport temperature-sensitive medications across the transformed world. Vaccine distribution, which requires maintaining cold chain temperatures of -70 degrees Celsius for certain vaccines, becomes complicated by transportation routes that no longer follow familiar geographic patterns. Pharmaceutical companies that invested billions of dollars in global distribution networks find their logistics systems unable to function reliably without GPS navigation and predictable transportation times. Medical devices that rely on satellite communications for remote monitoring and telemedicine services lose connectivity as satellite networks fail to provide consistent coverage across the flat Earth. Pacemakers and insulin pumps that transmit patient data to healthcare providers through satellite links now operate without the monitoring capabilities that prevent medical emergencies. The healthcare industry, which increasingly depends on connected medical devices worth hundreds of billions of dollars globally, faces significant challenges maintaining patient care without reliable satellite communications. Emergency services that coordinate rescue operations using GPS navigation and satellite communications find their response capabilities severely compromised on the flat Earth. Search and rescue operations that previously used GPS coordinates to locate aircraft crashes maritime emergencies, and missing persons now lack the precise positioning data needed for effective responses. Coast Guard services that patrol millions of square miles of ocean using GPS navigation systems now face vast areas of water where traditional navigation methods must replace satellite-based positioning. The insurance industry confronts unprecedented challenges as risk models based on spherical Earth geography become obsolete overnight. Property insurance rates calculated using hurricane models that assumed spherical storm paths now require complete recalculation for storms that move across flat surfaces. Maritime insurance that protected cargo shipments along established spherical trade routes now faces entirely different risk assessments for vessels travelling across the flat Earth's altered ocean geography. Agricultural insurance that protected farmers against weather-related crop losses using historical climate data from the spherical Earth now lacks relevant precedents for the flat world's new weather patterns. Crop insurance programs that covered hundreds of millions of acres of farmland worth trillions of dollars now require new risk assessment models based on the flat Earth's unprecedented climate dynamics. Space exploration programs that planned missions based on orbital mechanics around a spherical Earth now face fundamental questions about the nature of space itself above the flat disk. NASA's Artemis program, designed to return humans to the Moon at costs exceeding $93 billion, requires complete mission redesign if the Moon and other celestial bodies now relate differently to a flat Earth. Mars exploration missions that assumed interplanetary trajectories calculated for a spherical Earth now face navigation challenges that may render current spacecraft unable to reach their destinations. The International Space Station program, representing investments of over $150 billion from multiple nations, now operates above a flat world where its orbital mechanics follow entirely different physical laws. Spacecraft designed to dock with the station using navigation systems based on spherical Earth physics now attempt rendezvous maneuvers in a space environment where traditional orbital mechanics may no longer apply. Satellite manufacturing industries that built spacecraft worth billions of dollars for deployment in Earth orbit now face markets where existing satellite constellations may become obsolete. Companies that invested heavily in satellite internet services find their business models challenged by a flat world where satellite coverage patterns follow entirely different geometries. Mining operations that extracted resources based on geological formations developed over millions of years on a spherical Earth now work in a landscape where mineral deposits occupy entirely different positions. Gold mines, copper mines, and oil drilling operations that represented trillions of dollars in global investment now face uncertainty about the locations and accessibility of resource deposits on the flattened world. The energy sector faces unprecedented challenges as oil and gas reserves that were mapped using seismic surveys based on spherical Earth geology now require complete reassessment. Oil companies that invested hundreds of billions of dollars in drilling operations based on three-dimensional geological models now work in a flat world where hydrocarbon deposits may occupy entirely different underground formations. Natural gas pipelines that transported energy across continental distances on the spherical Earth now connect regions that occupy different relative positions on the flat disk. Coal mining operations that supplied electricity generation facilities with fuel, transported along established rail networks, now face transportation challenges across the altered geography of the flat Earth. Power plants that burned coal shipped from specific mining regions now require new supply arrangements, as traditional transportation routes no longer connect fuel sources with generation facilities in predictable ways. Nuclear power plants that operated using uranium fuel transported from mines around the spherical world now face supply chain disruptions as mining operations adapt to the flat Earth's transformed geology. Nuclear reactors that generated approximately 10% of global electricity using fuel supply networks, worth billions of dollars, now require new logistics arrangements to maintain power generation. The tourism industry, which employed hundreds of millions of people and generated trillions of dollars in annual revenue, faces complete transformation as travel between destinations requires entirely new transportation arrangements. Airlines that offered flights between popular tourist destinations now discover that journey times and routing options have changed dramatically across the flat Earth's altered geography. Hotels and resorts that catered to travellers following predictable seasonal patterns now serve visitors whose travel decisions respond to the flat world's new climate cycles. Cruise ship operations that offered voyages around the spherical world now plan itineraries across flat oceans where distances between ports follow entirely different patterns. Cruise lines that invested billions of dollars in ships designed to navigate spherical ocean routes now modify their vessels for flat Earth navigation while developing new destination packages for passengers exploring the transformed world. Theme parks and entertainment venues that featured attractions based on spherical Earth geography now update their exhibits to reflect flat Earth realities. Educational programs that taught geography, astronomy, and earth sciences using spherical models now develop new curricula that explain the flat world's unique characteristics to students who must understand their transformed environment. Transportation infrastructure that connected cities and regions across the spherical Earth now serves communities whose relative positions have shifted on the flat disk. Highway systems designed to connect population centres using great circle routes now follow paths across flat terrain that may require significant modifications. Railways that transported passengers and freight between cities using routes optimized for spherical geography now operate across landscapes where traditional transportation corridors may no longer provide the most efficient connections. Port facilities that handled cargo shipments from around the spherical world now serve vessels arriving from entirely different directions across the flat Earth's oceans. Container ports that invested billions of dollars in loading equipment and storage facilities designed for specific shipping lane patterns now adapt to cargo flows that follow new routes across the transformed world. The implications of a flat Earth extend beyond immediate logistical challenges to fundamental questions about physics, cosmology, and our understanding of reality itself. Scientists who spent careers studying planetary formation, stellar evolution, and cosmic structures based on spherical celestial mechanics now confront a universe where their foundational assumptions require complete re-examination. Research institutions that invested billions of dollars in equipment designed to study spherical planetary physics now redirect their efforts toward understanding the unprecedented physical laws that govern a flat world suspended in space. As this first day of the flat Earth draws toward its close, with the sun following its spiral path toward the outer regions of the disk, humanity begins to grasp the magnitude of transformation that has occurred. Every GPS receiver showing error messages, every flight grounded due to navigation failure, every weather forecast that fails to materialize according to familiar patterns serves as a reminder that our world has fundamentally changed overnight. The Antarctic ice wall that now forms the rim of our flat world stands as perhaps the most visible symbol of this transformation. Rising nearly 2 miles above the surrounding ocean, this barrier of ice contains more frozen water than any human structure in history. Expeditions that attempt to approach the wall discover that it extends both above and below the ocean surface, creating an impenetrable boundary that defines the limits of our transformed world. The wall's presence raises profound questions about what lies beyond its frozen surface, and whether the familiar universe we once knew continues to exist outside the boundaries of our flat Earth. In research stations scattered across what was once Antarctica, scientists now find themselves positioned along the rim of the world rather than at its southern pole. These facilities, which previously studied climate change and atmospheric physics at the bottom of a spherical planet, now investigate the unique conditions that exist at the edge of a flat world. Ice core samples that once provided evidence of global climate patterns over hundreds of thousands of years now offer glimpses into the atmospheric history of a world whose geometry has been fundamentally altered. The aurora phenomena that previously appeared in oval zones around the magnetic poles of the spherical Earth now manifest as displays that follow the flat world's altered magnetic field patterns. The northern lights, which delighted observers at high latitudes on the spherical planet, now dance across skies above the central regions of the flat disk in patterns that reflect the new electromagnetic environment created by the world's transformation. Weather stations that monitored atmospheric conditions across the spherical Earth now record temperature, pressure, and humidity data that follows entirely different patterns on the flat surface. Meteorologists who predicted weather systems based on atmospheric dynamics around a rotating sphere now develop new forecasting methods for air masses that move across a flat surface according to unfamiliar physical principles. The Coriolis effect that influenced storm formation and ocean currents on the rotating spherical Earth now manifests in different ways across the flat world's unique geometry. Ocean currents that previously circulated in great gyres around the spherical planet now flow in patterns that redistribute heat and nutrients across the flat Earth seas according to new hydrodynamic principles. The thermohaline circulation that drove deep ocean currents around the spherical world now operates according to different density and temperature gradients across the flat ocean basins. Marine ecosystems that evolved over millions of years in response to spherical ocean circulation patterns now adapt to current flows that follow entirely different paths across the flat underwater landscape. Continental drift and plate tectonics, which shaped the spherical Earth's surface over geological timescales, now require new theoretical frameworks to explain how land masses might move across a flat surface. Earthquake monitoring systems that tracked seismic activity around the spherical planet now detect tremors that propagate across flat continental plates according to different geological stress patterns. Volcanic activity that previously followed patterns related to spherical plate interactions now manifests according to entirely new geological processes operating beneath the flat surface. The moon, sun, and stars that illuminated the spherical Earth now provide light to the flat world according to celestial mechanics that challenge existing astronomical theories. Tidal patterns that previously responded to lunar gravitational effects on spherical oceans now follow cycles that reflect the moon's influence on flat seas. The phases of the moon that marked time passage for civilizations on the spherical Earth now appear according to the celestial body's relationship to the flat disk's geometry. Seasonal changes that resulted from the spherical Earth's axial tilt and orbital motion around the Sun now occur according to the spiral path that solar illumination follows across the flat surface. Agricultural cycles that evolved over millennia in response to spherical seasonal patterns now adapt to growing conditions that change as the Sun's path expands and contracts across the disk throughout the year. As humanity confronts this transformed reality, the resilience and adaptability that have characterized our species throughout history begin to assert themselves. Engineers design new navigation systems that work without GPS satellites. Meteorologists develop weather prediction models adapted to flat Earth atmospheric dynamics. Pilots learn to navigate using visual landmarks and dead reckoning techniques across the altered geography. Farmers adjust planting schedules to match the flat world's new seasonal patterns. The flat Earth presents humanity with its greatest challenge and perhaps its greatest opportunity for innovation and cooperation. International organizations that previously coordinated activities across spherical geography now facilitate collaboration between nations whose territories occupy entirely different relative positions on the flat disk. Scientific institutions that studied spherical planetary processes now redirect their research toward understanding the unique physical laws that govern flat world dynamics. Educational systems that taught students about spherical Earth geography, astronomy, and physics now develop new curricula that explain flat world science while maintaining the critical thinking skills necessary for understanding natural phenomena. Libraries and museums that preserved knowledge based on spherical Earth realities now serve as bridges between the old understanding and the new knowledge that emerges as humanity explores its transformed environment. The transformation to a flat Earth ultimately reveals the remarkable adaptability of human civilization and the power of scientific inquiry to understand even the most unprecedented changes to our reality. As the Sun completes its first spiral journey across the flat Earth's surface, marking the end of this extraordinary day, humanity prepares to explore and understand a world that challenges every assumption while offering unlimited opportunities for discovery, innovation, and wonder at the magnificent complexity of existence itself. This flat Earth, impossible as it seems according to our previous understanding of physics and cosmology, stands as testament to the universe's capacity for transformation and humanity's endless ability to adapt, learn, and thrive in the face of the most fundamental changes to the nature of reality itself.